sled dog in the figure drags sled A and B across the snow. The coefficient of friction between the sleds and the snow is 0.10. If the tension in rope 1 is 150 newtons, what is the tension in rope 2?
Okay. So what would the free body diagrams look like for each of those sleds? Actually, yeah.
Okay, so we got the first sled, A, is 100 kilograms. And so its net force would also be 100 kilograms.
So it'll have a gravitational force of 100 times 9.8.
And its the normal force is the same.
Right.
Let's see, the coefficient of friction on the sleds is 0.10. So we take that times the mass. Is that how we did that?
Times the normal force.
Oh, times the normal force, right. So we're 100 times 9.8 times 0.1. So it's 98 is the
Okay.
normal.
So that's your friction. And then how much tension did it say it had on the rope?
Let's see, in rope 1, this is actually, we're doing, yeah, that's right. Rope 1 is 150 newtons.
Okay. So this is 150.
Yeah. And then it's attached to sled B.
80 kilograms?
Uh-huh.
So it'll have the same things.
3 times 9.8. This times 0.1. So we're 78.4 on our kinetic friction.
Okay. Now, because they're attached to each other, what will this tension do to this?
Be the same.
Right, but going which direction?
This way. Towards the.
Well, so this is like rope 1. It pulls on both of them. And then there's a rope 2 over here, right?
Uh-huh.
So think about, so you ever like pull the sled behind you and you're pulling it, maybe somebody's sitting in it, and they feel the force of you pulling on them, but what do you feel in your hand?
Then pulling back.
Yeah. So this rope, because it's tied from here to here, it'll have a force exactly the same. This is a massless string approximation.
Okay.
Okay. So that's the tension in rope 1. It's the same pulling back on B as it is pulling forward on A.
Okay.
So then rope 2 just goes like this. It's tension 2.
And that's the sum of all of the X forces.
Not. It would be if they weren't moving, right? But will this force be equal to these two forces? No, because it's accelerating that way, right?
Okay.
Okay.
Okay. So, let's see. We don't know the acceleration.
Okay. Do we know enough here to find an acceleration?
I don't know.
So let's just ignore B for a minute.
Okay.
If we just look at A, what's the sum of forces in X?
Oh, okay, so if we take 150 minus 98, we get 52. So that's the... Okay.
That's
so
your net force in X.
net force, okay. So we can solve acceleration from that by dividing out the mass, which is 100.
Yep.
Okay, so that gives us 0.52.
Okay.
And they're both going to be going that fast.
Right, because they're tied together.
This is insane. This always blows my mind when
When it starts to work.
Yeah.
So what's the sum of forces in this one?
Okay, so we got Let's see, 150 is the tension on the rope, plus 78.4.
What sign do you want to make those ones though?
Negative, they're both
Yeah.
negative, so 50 plus 78.4, so it's negative 228.4.
Okay. Then how do you factor this in?
Okay, I got this, tension. We can solve that with acceleration now, right?
Right. So this would be a force you add on, right?
Uh-huh.
So plus T2.
Uh-huh.
This is plus T2. And that's all equal to what on this side?
Mass times acceleration, so
So
mass
80.
times. Yeah. So let's see, 80 times 25.2 is 41.6.
Okay.
These are actually kind of fun when you know it.
Yeah, when you figure it out.
Yeah. Okay, 41.6. Let's see, so we just